Hi and welcome to video 15 from topic on loans, investments and annuities, Unit 4, topic 1 of the General Mathematics curriculum. And in this video we're going to talk about the actual formula for reducing balance loans. So this is a bonus. We've been doing a lot of tables, a lot of long-winded repetitive calculations. We're going to see this formula. The good news is you don't need to know where this formula came from, and the other good news is that there is a variation of this formula on your formula sheet. So let's have a quick talk about this. Tables and spreadsheets are great. There's no question there. But an exam question might come up and say something like this. Andrew loans $80,000 and pays it off weekly at $160 per week. He's charged interest of $2.90 or 2.9% per annum for the loan. Well, even without interest, this loan is 500 times $160. Now it is per week, so that's only 10 years, but it's still a massive table. 500 rows in a table at least. That doesn't even include interest, so it's going to be more than that, maybe 550, maybe 600. That's a huge table. Furthermore, you're in an exam, so there is no spreadsheet, so you can't even do the spreadsheet method. So what do we do instead? Well, we did learn recursion in the calculator. You press, and try this now if you want, 80,000 equals, set it up as your answer, and then answer times 1 plus 2.9 over 5,200, that's 52 weeks in a year, times by 100 to make it a decimal, and then subtract 160, that repayment, and just press enter, and press enter again, and keep on pressing it till you get down to 0, and it's going to take at least, as we've said, 500, but probably something more like 600 times before you get to 0. And if it was me, I would definitely lose count at some point there, which would come from me losing focus. I reckon somewhere around about the 7th or 8th calculator click. So we need a better way, and here it is. Here's the annuities formula. This is what you get in your textbook, which varies slightly from what you get in the QCAA formula sheet. So I really want to bring these two things together if I can. So in the textbook you're presented this formula here, and they really use it. It's quite a robust formula. I quite like it. It's just a variation of the other formula from the formula sheet. What this formula does is it takes into account the growth of your loan, and then it takes into account an annuity that represents the decay of your loan. So this first part is the amount you first borrowed growing over time, and this second part is the amount that you're paying off as an annuity, as a summation annuity, which we'll see in the next part of this lesson series. And that works really well because at some point the second part overtakes the first part and then you've paid it off. So it's nice. This is really quite important, this one, for if you want to know how much you still owe after a certain time period. If after 3 years you want to know how much you now owe, particularly if you change loans, you change interest rates, something like that, that becomes a really important formula. QCAA don't provide that formula, but they kind of do. So you just need to know how to deal with it. So first of all, QCAA provide this exact formula. It's called the present value formula. It's here in blue, and it represents, for a completed loan, how long it will take to complete. So A is your present value and M is your repayments. And if you rearrange that, it's based on the fact that if we rearrange this formula and we let the A in this formula be 0 because we want to pay it off, then the P in this formula becomes the A. So you've got to be a bit careful the A and P swap around here, which is where the formula sheet and the textbook don't really link up. But in this first formula, A is the present value, the amount that you owe, M is how much you're going to pay, I is the interest rate, and N is the amount of time. So if you know something, you can find any of those other values. Say, for example, you know you owe $50,000 and you've got 5 years to pay it off, and you know the interest rate, you could work out how much you have to pay per month to pay it off. And you could use this formula to do it. And you could work out the time it's going to take, or the interest rate you need to attain to pay it off, for example. The second one, though, is for an incomplete loan. Really handy if you want to know, well, how much do I still owe in a few months? And how much do I still owe will be this A. It has a different meaning for the A's. Whereas this P will be the principal amount, how much you originally borrowed. M is the amount you're paying off per month. The I and the N are the same. Now, this second one, like I said, this second formula, not provided by QCAA, but kind of provided by QCAA. It's here in yellow and up here in green. So if you know that you just need to do this green one, subtract this yellow one, you get that kind of mid-loan appraisal formula that you need. And so we'll practice this in class. I'm going to do a couple of questions on this video, but we'll do some more in class to practice it further. So let's have a look at an example. And I really encourage you to be thoughtful about how you set up your work for these. Anita loans $20,000 and repays it off at $50 per week for 5 years. If the loan's interest rate is 5.2% per annum, calculate the balance remaining on the loan. So here's the formula. You can get that straight off the formula sheet. This was the yellow bit and this was the green bit. Now I'm going to write down everything I know and what I'm trying to find. This formula has 5 unknowns. A is actually what I'm trying to find, how much is remaining at the end. P is the principal, $20,000. M is the amount I'm paying, which is $50, but it's per week. So N is 5 years, but it's per week, so 5 times 52. And the interest rate is 5.2 over 52, and that's a percentage, which actually equals 0.1%. So isn't that nice? There we go. So A is equal to 20,000 times by 1 plus, now 0.1%, it's still a percentage, 1 plus 0.1 over 100 to the power of n, which is 5 times 52, 260, minus m, which is your repayments, times by 1 plus 0.1 over 100 to the power of n, 260, minus 1, all over 0.1 over 100. And now you can do this in multiple ways. What I'll do is, just so you've got the answer to check with, is I'll evaluate the first one and then I'll evaluate the second one, and then we'll do the subtraction last. So the first one is 20,000 times, I'm using brackets, 1 plus, I'm using the fraction bar, 0.1 over 100, closing that bracket and raising to the power of 260. Enter, and it gives me this. 25935.23 minus, now I'll do the other one. I've got to be really careful with this one. So I'm going to set up a fraction bar first, 50 on top, times bracket, 1 plus, and then another fraction, 0.1 over 100, close bracket, to the power of 260, minus 1, close that last bracket, and then all over another fraction bar, 0.1 over 100. Be really careful, make sure you get it right. Now those repayments then are worth 14,838.08. So, well, that should be right. So this bit is how much that loan is worth after 5 years, how much interest is accrued on it. But this bit is my repayments and how much that's worth after 5 years. And if I do that subtraction, 25935.23 minus 14838.08, my remaining balance is $11,097.15. So there's the first one. And I've just literally written down what I know and then evaluated based on that. How much would Anita need to repay per month in order to have her own nothing after 5 years? So in this case, we go to that, it's a finished, completed loan stage. Now, I want A is the principal. I want to pay off $20,000, and then I want to work out my M value. My I value is 0.1 over 100 again, which incidentally is 1 over 1,000 or 0.01, and that's an I value as a decimal now. And N is 5 years, so 5 times 52 again, which is 260 incidentally. And so now I need to do that calculation of 260 and 0.001 and 20,000 in here. But I'm going to do a rearrangement first. So it's going to end up being that M is equal to A divided by that thing in brackets, 1 minus 1 plus I to the power of negative n all over I. So I might just do that substitution, which is 20,000 divided by 1 minus 1 plus 0.001 to the power of negative 260 all over 0.001, and so we get 1 minus, I'm going to work out the denominator first, 1 plus 0.01 to the power of negative 260. I'll evaluate that. I'm going to divide that by 0.001, and then I'm going to divide 20,000 by my answer. Oops, I've just done 20,000 times, divided by my answer. There we go. And that comes out as $87.39. Now it's actually 0.394, so what I might say is $87.40. We really should round up, because the way the question is read, and also with the underline there, how much would Anita need to repay per month in order for her to owe nothing after 5 years? Now the $87.39 is the closest value, but if I actually put that in as M, so if I calculate 87.39, because it was a slightly higher value than that, minus 1 plus 0.001 to the power of negative 260 over 0.001, I get this, 19999.04, or actually 05, which means I still owe 95 cents. And I know it seems trivial, but it means I don't owe nothing. So in this case, it would be appropriate to round up, and you've got to be really considerate of when it's appropriate to round up and when it's appropriate to round down, because sometimes it's important. But anyway, there's your two examples, a combined example. We could use a spreadsheet, which I'll leave with you, but this spreadsheet, if you open, and we'll do it in class, does come up with some just entry points that we can check our answers. But have a play with that, do some further examples, and I would just ask you, do you know how to use those annuities formulas? Can you calculate repayments, interest rates, amount able to be borrowed from a formula, and can you analyze by spreadsheet to investigate? And if you can do all of those, and you'll be successful, and you can finalize this chapter by working on 8C in the chapter review. All the best.